So you can see that I finished out the rest of those expected numbers, and I just wanted to make sure that we understand that the reason I did it this way is because these are all assumed to be equal. I mean, if you were working with this one with Mitt Romney and Rick Perry and so on, then you would take each of their own percentages and multiply it. So you'd say 0.32 times 1067 and 0.41 times 1067 and so on. But because we were working with this distribution that we assume every one of these is equally likely, right? Because it divides up the calendar equally, you don't assume that, more babies are born for Pisces than for Gemini and so on. All right, now there's our test statistic, but we'll see it when we get down here because you get to do a chi-square goodness of fit test. Woohoo! I knew you'd be excited. Okay, so the null hypothesis is that the random variable follows a certain distribution, and you can write that out with percentages, or you can say what the distribution is. Then you have your type 1 error, then you have your step 3. Now this is what we have to do. What I just did, calculating the expected counts, I just showed you how to do that. You verify the requirements of a goodness of fit test are satisfied, i.e. all the expected counts are greater than or equal to 1, but no more than 20% of the expected counts are less than 5, right? And then if the requirements are not satisfied, one option is to combine 2 or more low-frequency categories into a single category, which I don't think we'll have much need to do, but then we're going to compute this chi-square test statistic, and then we'll have the option of, hey, look, the classical approach or the p-value approach. Both these are with chi-square, and then we'll state our conclusion. Okay, so we showed earlier what we saw here. This was the distribution of astrological signs. So what they did was they polled 1,067 richest people in Britain, right there. And they said, okay, they noticed that there were a lot more Geminis that were rich than Pisces that were rich. So maybe being Gemini makes it easier for you to be rich. Who knows? Right? Now, this is what we observed, right? In real life, this is what happened. And then what we expected to have happen was what we had found before. And so what I'm going to do, hold on a second. Let me go to Excel here. I'm going to put in a column. Oh, no. Control Z, I'm telling you. You do something you don't like, you hit Control Z and it brings it right back. Okay, so what we observed, I'm going to highlight this column right here. I'm going to go here. Okay, so here's our signs, the 12 signs. Here's what we observed in real life. Here's what we expected. Okay, so now we're going to have to make some null and alternative hypotheses. And I'm actually going to fit it around this. So hold that thought 1 second. Okay, here we are. So the null and alternative hypothesis is that all the proportions are equal to each other. Oops, I should have said that equals 1/12, right? Because if they're all equal, then every month is equally likely. Then you have your level of significance, and it didn't give us one, so I'm just going to go with the old tried and true 0.05. Step 3 is the chi-square statistic, which is this big honkin' thing. And I'm going to use Excel to find it. Basically, you need to take the observed minus the expected. You need to square it and you need to divide it by the expected. But you're going to have to do it for everyone. So we're going to take OI minus EI, minus EI, square it and divide it by EI. And that's pretty much the formula you're going to do as well. So you say equals observed, so parentheses, observed minus expected, close parentheses, square it, divided by the expected. And for the record, I just want you to note that none of these expecteds were less than 5. So it said all expected counts are greater than or equal to 1. Well, we definitely have that. And no more than 5 of them are less than 5. Well, we didn't have any of them less than 5. So we have the assumptions in spades here, right? Remember, these are the expecteds, not these. And then the chi-square statistic, which will be the test statistic, is right here, which would be equal to the sum of all of these. All right, there's our chi-square statistic. Step 3 is done. Now we'll have to go figure out step 4, which will be needing another video because we don't have time for it in this video. But we did figure out this test statistic.